Alrighty, so in this video we're going to take a look at some practice problems using speed versus time graphs. What that means realistically is we're going to be calculating distance travelled using the area, and we're going to be calculating acceleration using the gradient. Okay, so the first question, determine the distance travelled in 6 seconds for both graphs. So the area under both of these graphs is a triangle, so we're going to be using half base times height. Both of their heights are 10. Both of their bases are 6, so we're actually going to get the same answer here. And actually for both of them, it turns out it's 30 meters using half base times height. Then determine the distance travelled in the first graph between 2 and 4 seconds. So the way I approach this is we can see after 6 seconds, it's got to 10 meters per second. So after 2, it's got to a third of that, and after 4, it's going to have got to 2/3 of that. So essentially, we're trying to find the area, which is now a trapezium, and we've got height on the left of 3 1/3, height on the right of 6 2/3, and when we multiply that by the half and by the base, we get a total distance of 10 meters. Okay, so we've got a different velocity versus time graph for a lunar lander. Calculate the acceleration. Well, acceleration is the gradient, and it's a straight line, so that's pretty easy. We're going to do change of velocity over change of time. So at the end of the time, it's at 8. It started at a velocity of 0, so we're going to do 8 minus 0. Divided by 5 gives us 1.6 meters per second squared. Calculate the distance it's travelled during the 5 seconds. It's going to be the area under this, so we're going to be doing half times base times height, so that gives us 20 meters. Okay, so we've got two sections of a car braking. We've got the thinking time, which is the time between the driver seeing an incident and actually applying the brakes. So they're going to go at constant velocity for that period because they're not applying brakes. And then the braking time, which is where we can see the velocity decreasing or decelerating to 0. So the thinking distance, or the distance travelled by the driver, is going to be the area up to 0.75 seconds. So that's a rectangle, so that's nice and easy to calculate the area of. It's just base times height, giving us 9 meters. And then the total distance, we're going to need to add on the triangular section. So we've got 9 for the rectangular section. The triangular section, we're going to do half times base times by height, and that gives us this value here. And then final problem in this speed time graph, we want to calculate the average speed for the following journey. So this is a tricky little problem, but is a nice once you see how it's done. So what I'm going to do is I'm calculate the total distance it travels, which I can then divide by the time it took to calculate the average speed. So the distance is going to be the area under the graph. So we're going to do a triangle for the first 20 seconds, a rectangle for the next 20 seconds, and then a triangle for the remaining 10 seconds. So we're going to do half base times height, base times height, and half base times height again, giving us a total distance of 1400 meters. And we know that distance was travelled in 50 seconds, so we can get the average speed during that period of time as 28 meters per second squared. And that finishes the set of questions just looking at speed time graphs.